Hi, this is Mrs. Bustamante. We're going to continue talking about kinetic molecular theory. So we're going to reference this picture here that you see. These are going to be molecules and the arrows are showing them the direction that they're going. So what does kinetic molecular theory tell us? It tells us that particles are in constant random motion. They don't have a direct path. They're just going wherever they might want to go. They don't have a plan, so to speak. They move in straight lines until they bounce off each other or walls. Basically, until they hit something, which you can see in these arrows, they're going to move in straight lines. And if they do hit something, well, they'll bounce off. Or if they hit each other, they will bounce off too. And we say that these collisions that are happening are all what we say perfectly elastic. We're not going to lose any kinetic energy between molecules. It might transfer, it might move a little bit, but that kinetic energy we had before is going to be there after. So just to give you an idea, the average speed of an oxygen molecule is 1,656 kilometers per hour at 20 degrees Celsius. This idea of Celsius and temperature was going to become important here in a second. And the molecules don't travel very far without hitting each other or hitting something else when they move in these random directions. Just to give you an idea of what we're talking about when we're talking about molecules moving, right? So the other thing we need to know in order to understand this unit is kinetic energy and how it relates to temperature. So temperature is really just a measure of the average kinetic energy of the molecules a substance has. At the same temperature, all molecules have the same kinetic energy. Now the kinetic energy equation is that we have 1/2 your mass times or multiplied by your velocity squared. So we know that not all molecules have the same mass, but if they have the same kinetic energy, that means some molecules can move faster or slower depending on their mass in order to give them the same kinetic energy. Really, we know that at the same temperature, small molecules or molecules that have smaller mass are going to have to move faster in order to have the same amount of kinetic energy. And we need to know that at absolute zero, this temperature called 0 Kelvin is a temperature at which we say all molecular motion would stop, meaning these particles wouldn't be moving or bouncing into each other or anything anymore. They would actually be still. So kinetic energy relates to our changes of states of matter. We said that temperature and kinetic energy are the speed at which something is moving, and so they're directly proportional. What that means is if we see the temperature increase, we would also see the kinetic energy of our system increase. That's what directly proportional means. When one goes up, the other goes up. So they are directly related. They will both go up or both go down. A lot of times we use something called the Kelvin scale, and we're going to use the Kelvin scale in this unit because it doesn't have negative numbers, which is really nice when we're doing particularly fractions and trying to determine relationships. Because it has this thing called absolute zero that we just mentioned on the last slide, where all matter stops moving, where those particles wouldn't be moving anymore. But we don't measure a lot of temperature in Kelvin every day. So we need to know how to convert between Kelvin and degrees Celsius and Celsius and degrees Kelvin. In degrees Celsius and Kelvin. Now you should note that we don't say degrees Kelvin, we just call it Kelvin, unlike all the other things we kind of know about with temperature when we talk about degrees Celsius or degrees Fahrenheit. It's just Kelvin. And so how do we do that? We add or subtract 273 depending on which we're looking at, right? So if we want to get a temperature into Kelvin, we would take our Celsius temperature and add 273. That gives you your temperature in Kelvin. And the mass and the speed of particles, remember kinetic energy is 1/2 times your mass times your velocity squared. And so that means they are directly proportional to our kinetic energy too. The mass divided by your velocity is directly proportional to your kinetic energy.